part 2, I will go over the object syntax, this new way of thinking about programs and things as objects. So, starting from scratch, and go through these motions rather quickly because by now we've had 15, 14 weeks together. You should have these things be pretty automatic. Okay, so function setup and draw. We're going to make a canvas. And what I'll do differently this time is have direction variables, like in Tron. If you're moving up, then it should be true. If you're moving down, the up variable should be false, yada, yada, yada. So let's see how fast Mr. Chan can code up some of these things. Okay. Cool, there's my circle. All right, and so as I'm coding up my circle, function ball, this ball is going to move left and right. Ball will move, it will bounce left and right. Move and bounce off the left and right walls. So the previous example I had, it bounced up and down. Now it goes left and right. If I give you this code, you'll see an insight on how to make it bounce diagonally. And I'll also go, if there's time, I'll go over one of the common bugs. It's stuck always going diagonal. Okay, it should just go bouncing around like this if you see my mouse positions. But often when you're trying to combine the left and right and the up and down code, your ball gets stuck doing this always, or like this always, along this axis, as my mouse is demonstrating. Okay, so as we create a function ball, if we look at the assignment prompt, it walks you through some of these objects. A ball object should have an x and y coordinate. It should have a direction for its up direction and a right direction. So let's add that in. This dot x equals the center of the page. This dot y equals, let's make it a bit more interesting. Instead of having it start always in the same spot, you have random. You could round random and have it start at some round the random function. Start somewhere on the screen, maybe from like 80 pixels up to 180. So now its y position varies a little bit. So each time we create a new object, it has something special about it. If I'm creating some direction variables, this dot right equals true. Why is it doing this? This dot up equals false. For this example, I'm not really going to use the up direction, but if you're doing a bouncing ball, this is more aligned with what the assignment prompt says, and one way you could have coded up Tron. My previous example used speed, and if I have speed, it has direction and a slope to it. Direction and speed has a direction and like a magnitude. So it says like 1, right? 1 is the magnitude, negative or positive is the direction. So we're kind of breaking that up in these functions. What else? I need this dot, why is it doing this? Tidy.js. I guess it already is tidied, weird, okay. So this dot move, we need a move function. This dot move equals function, and we're going to define it here. This dot show, we're going to define it here. Careful with your parentheses. When I was walking around helping some students, these squiggly braces, squiggly brackets are often imbalanced, and then you're asking me why my code doesn't work. Okay. So what does it mean in the move function? Well, that is checking if your direction, so if I'm moving right equals true, then right means I'm adding to my x position. This dot x equals this dot x plus 1. Otherwise, right, there's multiple ways we can code this part up. Otherwise, you could do else if this dot right equals false. And of course, this dot x equals this dot x minus 1. That's one way to code it up. You could have also just used else. And for example, that would look like this. This would have worked too, else. Because the opposite of right being true is in fact right being false. Let's be explicit about it. That's what it means to move. Notice the usage of these variables. Okay, these booleans. Booleans are just fancy, the simple variables that are either true or false, 0 or 1. It switches between two values. In show, we have our ellipse function. It shows at this position, this dot x, this dot y. And we're just going to have it always be 50-50. Bouncing, that's the new part. We've kind of broken this up into two steps. Previously, I think I condensed it. Did I bounce? My memory is a little vague on that. So bouncing now uses those directions. Okay, if you get to the right wall, which is x being greater than 200, that's the size of my canvas, then this dot right equals false, because now you want to go left. So I'll write the plain English for that. When my x coordinate touches the right wall, then you want to move left. Then your direction will be left, not right. So that's what this code means. If x is less than 0, let's leave less than equal to 0, then this dot right equals true. And in plain English, when I arrive at the left wall, I need to change my direction to move right, not left. Okay, save and run. We currently just see the nothing. I've done something drastically wrong in my setup. So let's now debug. So I have my if statement, my if block here, this thing. Do my function syntax correct? I think so. Bounce, show, and this one's move. Why does this one look funny? Why is my indenting so weird? Function ball, this dot right, round, oh, that's why. Da. Okay, now it will tidy. Fix my indenting. So notice it starts at a random y direction. This is what it means to move. This is what it means to show. This is what it means to bounce. Now if I run my code, I should see that sphere, that circle be there. Great. I have not used my code yet, so I need a name. Computer scientists like Bob for some reason. They also like Alice. They also like the word food and bar and goo. I don't know why. In setup, let's initialize it. Bob equals new ball. And now let's use our new ball. Bob, show yourself. Neat. Bob does not want to show himself. What did I do? Bob.show, draw. Is it, I'm out off the screen? Is that why? Right, false. Bob.show. This, oh, right there. Nasty little bug. A period instead of a comma. Alright, save and close. Run. Ah, there's Bob. And now you'll see that y random variable come into play, okay? Each time Bob is in a different y position, when I run this code, Bob starts in a new place, okay? You see that bit of randomness. And notice Bob is not moving yet because I didn't tell Bob to move. So Bob, please move now. Bob, move yourself. Do-do. Hey, Bob moves. Oops, I forgot the background. Let's delete that previous ellipse and draw in our 150 gray background. Ta-da! Blast, doesn't bounce. And then we see that randomness still be at play, right? It starts at a different y position each time. Woo. And there's your bounce code, bob.bounce. Hey Bob, when you get to the edge, change your direction. And it performs it doesn't work. What have I done? Bob does not in fact bounce. Did I initialize it to greater than, oh, haha. So this x coordinate currently has no meaning. It doesn't belong to anyone. You need this dot x. You're referring to the specific ball's x coordinates. I run my code. Now you shall bounce. Da-doop, da-doop, da-doop. Okay, and let me show you something else that's neat. What's nice about objects is now, instead of copying and pasting some code to get different bouncing balls that bounce according to different speeds or positions or colors, you can now add a little something in this definition. For example, let me give it a number. This one will correspond to size, right? Okay. And now down here, notice I added it up here. Now I'm going to create a variable here that is how big you are. Okay, that's my member variable. This dot how big you are equals size. And each time I draw, instead of doing 50-50, it's going to be this dot how big you are. And I'm hoping I will now demonstrate down here. When I create a ball, notice if I save and run now, my code breaks. Bob no longer exists. Because this old definition of using this ball, the computer doesn't know what that means. So how big you are. If I put in 10 now, the computer does know what that means, because that number that I pass in corresponds to size. Notice Bob is very tiny now. Bob is very big now, because I turned it 10 times as big. Wow, Bob, how large you are. Right? Bob, what's large Bob? Yes. You've grown so much, Bob. Yes? And now, maybe Bob has a friend. Bob's friend is Joe. Hello, Joe. Joe, you are also a new ball. And we're going to create, Joe's going to be the small one. Bob is the big one. Ta-da! They start at the same random position. Is that why I don't see them? Oh, right, because I didn't tell Joe to show himself. So again, for Joe, we got to do Joe, show yourself. Joe, move yourself. Joe, bounce yourself. Okay, now we have two balls on the screen. Ta-da! And they all start at different X positions. Ooh, look. Now Joe's on top. Correct. And they bounce at the same speed. Oh, now they're on top of one another. Physically. And so, that is one change you can do to these kinds of functions. Notice, like for an ellipse, you pass in an x, y, and a width and a height. You can now be even more specific with your objects. These are your variables, okay, because you created them. You have the power. That ends my lecture for today. Work on your assignments. There's about 15 minutes left. Jesse and I are here next week, Tuesday, correct? Yes.